Okay, I'm going to work some of the odd problems from the first section of the book, from the first section of chapter 4.1. This is where we were going to have to look at an equation, decide whether it's a polynomial, and then if it is, write the degree, the type, and the leading coefficient. So for problem number 3, the first thing I'm going to do is look at the coefficients. The coefficients cannot be imaginary. So if there's an I in there on the coefficients, then it's not going to be a polynomial. I have a -3, 5, -6, and 2. Those are all real numbers. None are imaginary. So my coefficients are okay. Now let's look at the exponents. They have to be 0, 1, 2, 3, or 4. No negative numbers, no variables, no fractions. So I've got a 1, a 3, a 2, and a constant term. So my exponents are okay. This is a polynomial. Now that I know that it is, I have to write it in standard form. So I'm going to write the terms so that the largest exponent comes first all the way down to the smallest. So that would be 5x cubed minus 6x squared. Then I have a term with a first power and plus 2. That's standard form. Then it asks me the degree. Okay, the degree is the largest exponent. That's 3. And then it says the leading coefficient. Leading coefficient is the coefficient that's on the term with the highest degree. That's 5. Then it asks me to name it, the type. Since it's a third power, we call that a cubic. Okay, the next one, I'm going to move to number 5. So let's look at the coefficients, a 9, an 8, a -6, and a 2. They're all real numbers. The coefficients are okay. Now let's look at the exponents. 4 is okay. 3 is okay. Oops, I have a -2. No negative exponents. So the exponents, no. So this is not a polynomial, and I don't have to do anything more with it. Looking at number 7, let's look at the coefficients. I have 5/3. That's a real number. It's not imaginary. Square root of 7. That's a real number. It's not imaginary. 8 and a -1/2. So the coefficients are okay. Let's look at the exponents. I have a 1. I have a 3, a 4, and a 2. They're all okay. So it is a polynomial, so we have to write it in standard form. That means the largest exponent is first. So that's a negative square root of 7x to the 4th. Now let's look for an x cubed term. There's one. See if there's an x squared term. Yep, 5/3 x squared. An x term. Yep. There's standard form. The degree is the largest exponent. The leading coefficient is the coefficient in front of the largest exponent term, negative square root of 7, and it's a 4th power, so we call that a quartic. Going to the next group of problems that we had, these are evaluate, so all I have to do is put the number that it's saying is x, put it into the equation. So I have x is a -2, so I'm going to substitute that in for all the x's in this equation. So I have a -3 times a -2 to the 4th plus 2 times a -2 cubed minus 12 times a -2 minus 6. So let's simplify. -2 to the 4th, that's 16. -2 cubed, that's going to be a -8. -2 times 12, that's plus 24. Okay, that's a -3. -3 times 16 is a -48. Minus 16 plus 24 minus 6. -46. Oh, that's not right. Okay, let's do the next one. So this one's got a fraction, so it's 2 times 1/2 cubed plus 4 times 1/2 squared plus 6 times 1/2 plus 7. So 2 1/2 cubed is 1/8 plus 4 1/2 to the squared is 1/4 plus 6 over 2. So this would be 2 over 8 plus 4 over 4 plus 3 plus 7, 1/4 plus 1 plus 3 plus 7, 11 and 1/4. Okay, the last kind of problems that we had were where we had to write the intervals, whether they're increasing or decreasing. We're not going to worry about part B. So all we have to do is let's say, where is this function increasing or decreasing? Well, at the bottom of this graph, it's going to change from going down to up. So it's decreasing here. If I was walking from left to right, I would be going downhill. So for all values of x less than x is less than 4, I'm going downhill. So let's go ahead and put decreasing and increasing. And then for these two graphs, we'll figure out where they're doing the decreasing and increasing. So we've already said that I'm going from left to right, so I'm going downhill all the way on any value where x is less than 4. So it's decreasing for x is less than 4. Then as soon as I get at the bottom, I start going back up. As x goes greater than 4, I'm going back up the hill. So that would be for values where x is greater than 4. Okay, moving down to 35. Okay, so I'm coming from left to right, and I'm increasing. I'm going upward. And I'm going upward all the way until I hit this value right here at x equal to 0. Then I start going downhill, so I'm decreasing all the way until I hit the value where x is equal to 2. Then I start going back up. So I'm going upward in these two areas where x is less than 0, and I'm going back up again where x becomes greater than 2. So x is greater than 2. Those are the two areas where I'm going up. Then the place where I'm going down is right in the middle. That's between the values where x is 0 and 2. So I would write that like this. 0 is less than x is less than 2. That signifies that x is between 0 and 2. And these will never have equal to signs because right at the place where like x is equal to 0, I'm not going up or down.